Hi everyone, welcome to our science series. My name is Lauren and I'm with Sci-Tech Discovery Center. Now today we're going to be doing an activity called Molecules in Motion. Now before we start this activity, I want you to take a look at this object in front of me. It's extremely easy for me to lift the lid off of the base. But if I seal it back up and attach this, and then just give it a couple of pumps, I now can't separate them. So today we're going to be answering the question of why I can't separate those two things. Now some of you already might be thinking that it has something to do with air, and you would be correct. Now this is a mini vacuum. What I am doing is I am actually pulling the air out of the container. This tube is a one-way valve. That means that things can travel out of it but cannot get back in. Now air is all around us. It might not feel like it, but it actually puts 15 pounds of pressure on you every day. Now we're used to it because air is just something that we have to live. However, when I move that pressure, it can do things like keep something sealed or create a vacuum effect. Now, if I remove this tube, the air rushes back in, and I can now lift this off. Now, this air pressure is something that we're going to use for our experiment today. So now that we know a little bit more about air pressure, what do you think will happen if I put this toy inside my vacuum chamber? Now, he's very squishy. So if I place him in here, and I have to make sure that he's entirely sealed up, no little parts poking out, seal him up, and start pumping some of my air. So let's watch. Look at that. He has grown. The reason that he got bigger and not smaller is because I am pulling the air out, but I'm only pulling the air out of the chamber. That means that there's still air inside my toy. Now, air molecules move extremely fast. Out of our three states of matter, liquid, solid, and air moves the fastest. So it's moving around. And as I pull the air from inside the chamber out, the air inside the toy now has more room to move around. And because the toy is squishy, it is able to expand because that air inside it is not pushing against the soft sides of the toy. But if I put the air back inside my plastic container, let's see what happens. The toy goes back to its original shape. That's because the air pressure is now pushing from the outside back onto the toy, squishing it back down. So that's what happens when I put something that is soft and malleable in there. What do you think would happen if I put something that's hard in there? So this is a normal ping pong ball, and I'm going to put it inside my chamber. Seal it up. Give it a couple of pumps. Pump, pump, pump. So at this point, this toy had already expanded. But nothing is happening to my ping pong ball. That's because it's made out of a rigid material, something that doesn't move as much. So even though I'm still taking the air from this chamber out, and there's air inside this ball, the air is moving around in there, but it's not strong enough to push the ball out like it was able to with something soft and squishy. But if I do this, you can see the air go back in. That was all the air rushing back in and making the ball jump because the air pressure was able to lift it. Now, for my final experiment, I have another little toy. So this is my unicorn, one of my favorites. I'm going to put him in the chamber and see what happens. So I seal him up, start pumping. Whoa! Just look at those eyes. So the same as the soft toy, I've removed the air from this chamber, but the air inside the toy is still moving around, and his little eyes are the softest part of him, so they've been forced with the air pressure to pop out. But when I reintroduce my air to the chamber, he goes back to his normal size. Now, air pressure is extremely important. We can use it on tools, and we also have to think about it when we go into outer space, because the lack of air pressure can also do extremely dangerous things to our bodies. So that's why we have to use rigid materials to protect our astronauts. I want you to try and think about how air pressure has affected you, or how it could possibly affect the materials around you. A good thing to look up is to go online and start looking at some of the information that we have on our astronauts' spacesuits and on their spacecrafts. So thank you so much for tuning in. Feel free to leave a comment below, or if you have any questions, please contact us at Sci-Tech Discovery Center.